Imagine a time before time existed. There was no space, no stars, no planets, not even emptiness. Then, in an instant, everything changed. This is the story of the Big Bang, the event that created our universe. It's a story of incredible energy, mind-boggling expansion, and the birth of everything we see around us. Get ready for a journey back to the very beginning of time. The Big Bang wasn't an explosion in space, as you might imagine. Instead, it was a rapid expansion of space itself, a phenomenon that marked the very beginning of our universe. It was the expansion of space itself. This means that every point in the universe was once compressed into an incredibly small, dense state. Imagine a tiny, incredibly dense point suddenly expanding. This point, known as a singularity, contained all the mass and energy of the universe. This expansion happened everywhere at once, creating space and time as it went. It wasn't just matter that was spreading out, but the very fabric of space-time itself. In the first fraction of a second, the universe was unimaginably hot and dense. Temperatures were so high that particles couldn't even form atoms. But as it expanded, it cooled, and the building blocks of matter began to form. This cooling allowed quarks to combine into protons and neutrons, eventually leading to the formation of atoms and the complex structures we see today. As the universe cooled, energy transformed into particles, giving birth to protons, neutrons, and electrons. These subatomic particles were the building blocks of everything we know today. These particles didn't remain isolated for long. They came together to form the first atoms, primarily hydrogen and helium, the simplest and most abundant elements in the universe. This marked the beginning of the cosmic chemistry that would shape the universe. Over millions of years, gravity, the invisible force that governs the cosmos, pulled these atoms together, forming enormous clouds of gas. These clouds, rich in hydrogen and helium, were the nurseries of the universe. Under the relentless pull of gravity, these gas clouds collapsed further, their cores heating up until nuclear fusion ignited, giving birth to the first stars. These stars were the first beacons of light in the dark universe. Stars lived out their lives burning hydrogen into helium and creating heavier elements in their cores through nuclear fusion. When they died, they exploded in supernovae, scattering these elements across the cosmos. These scattered elements would eventually coalesce to form planets, moons, and other celestial bodies. From these elements, the building blocks of life emerged, setting the stage for the complex tapestry of life that we see today. The Big Bang theory is the best explanation we have for how our universe began. It suggests that the universe started from an incredibly hot and dense point approximately 13.8 billion years ago. This monumental explosion set everything into motion, creating the building blocks of matter and energy that we observe today. It's supported by a lot of evidence, like the fact that the universe is still expanding today. Observations from powerful telescopes show galaxies moving away from each other, indicating that the universe is stretching out over time. This expansion is a key piece of evidence that supports the Big Bang theory. By studying the Big Bang, we learn about the fundamental laws of physics and the origins of everything around us. Scientists use advanced technology and theoretical models to understand the forces and particles that emerged from this event. This research helps us comprehend the nature of space, time, and the very fabric of reality. It's a story that continues to amaze and inspire us, reminding us of the vastness and wonder of the cosmos. The more we learn about the Big Bang, the more we appreciate the complexity and beauty of the universe. It's a journey of discovery that fuels our curiosity and drives scientific exploration. Like and subscribe for more out of this world content.